Department of Mathematics, Kailash Women's College, Nangavalli. Let us discuss the topic of transportation problem. The object of transportation problem is minimum cost. The first starting point of the supply center is called sources and receiving centers are called the destination. The minimum cost is total distribution is minimum cost. The next condition of the transportation problem is total supply must be equal to the total demand, that is called the balanced transportation problem. Another one is unbalanced transportation problem. Unbalanced transportation problem, we have to convert the balanced transportation problem. For example, first example for the balanced transportation problem, total supply is equal to total demand, that is the values of 40, both sides are equal, that is the balanced transportation problem. Another one example of unbalanced transportation problem, the supply's total values is 40 and demand total values is 50. So we equal to the values of supply, we introduce the dummy row, the values of 0, then value added by 10 in supply the values. Next one, initial solution of transportation problem. Three types of initial solution. The first type is northwest corner rule. Northwest corner rule method allocation will be in the north corner of the cost. The allocation will be the minimum values of S or D. The S is called the supply and D is the demand. The values satisfy both minimum values. We eliminate the variable of the row. Future consideration of the reduced demand is called by S. Otherwise, the D is eliminated, the column is satisfied, the column is reduced. Repeat the process until the supplies and demands are all of the values satisfied. Finally, we calculate the total cost of the transportation problem. The allocation will be in the cost and supply and demand all values satisfied. Finally, we calculate the total shipping cost is 2250. The next method is least cost method. Least cost method in the cost cell, which is the least value of the cost of the cell. We choose the minimum value in the cost. We allocate the cell by again supply and demand both are comparatively, and minimum value is allocation by choosing in the least cost, and both supply and demand all the values are satisfied in the least cost method. Repeat the process in the until supply have been allocated. Then supply completed will be demand also completed. Then finally calculate the total transportation cost. The least cost cell is first one is supply the values of 12 and demand values is 10. So the minimum values is 10, remaining balance is 2. Next one calculate that next values of x3 one cost is 40. Then row values is for 11 and column values is 10. So the minimum values is 10. We have to subtract the values of 1. So the process until by finally allocation completed, the least cost method is final calculated the total cost. The total cost is 2065. The third method is Barbell's approximation method. First point is for each remaining row and column, determine the difference between lowest two remaining costs in the row and column is called the penalties. Select a row or column with the largest penalty found in the step 1 and note the supply remaining values of its row S and demand remaining its column D. Then third one is allocated the minimum cost of the supply and demand variable in the selected row or column with the lowest remaining cost in the allocation of the cell. If the minimum cases, eliminate the variable in the row and future consideration and reduce the demand in its column by S. The column for virtual continuation and reduce the supply in the row by D. Repeat this process until the supplies have been allocated. Then VAR method is cost is 2030. The three methods is minimum cost is Barbell's approximation method is the best solution of the minimum cost. Today discuss the topic of transportation problem and its initial basic solution of the three types of the problem in the transportation problem, that is VAR method, LCM and NWC. The best solution of the method is VAR method.